Okay, my title is Elegant Mapping with GMT, but it's not very elegant because I forgot the logo of GMT. And you can find all the data, share scripts, and this PPT by this QR code, or you can ask me the link. So today I will present basically the maps in our recent paper with Milena, but I don't talk about the science. If you want to ask science, you can Milena is here. And here we did a lot of mapping for the seafloor and the sub-seafloor, so you can see the title. And so because our group, most of the people, we are working on the EPR, so it's a good example and good practice. So I will do the shape bathymetry, AUV bathymetry on different scale and the geology. So let's just start from the figure 1, the original map for the EPR bathymetry. So there are two things. The first is panel A is so you can see the bathymetry map, and the second is the globe. I know some people are struggling with this globe when they are doing mapping. So I will in the panel A I will do this, and the panel C is B is the AUV map. So normally when we do the mapping, we give longitude, latitude, and the left, right, and north, top and bottom. It's very complicated because you have to know the longitude, latitude, this kind of very, and when it's going to minus 104, it's very complicated. So here is the oblique Mercator projection. It's very easy to do the mapping. I can show you so we first look at the projection. So this one is the projection with Mercator. So this is, so we call, J is the projection. Here is the center of the map. And this one is the rotation. And 10 is 10 centimeter. So you have the center, you have the width, and you have the rotation. Then you just give left, right distance, top, bottom distance. Then you don't need to care about the longitude, latitude, and it's very easy. And
10 centimeters is the size of the figure that you want?
Yeah, 10 centimeters. And
in what direction?
The direction, you can rotate any angle.
I don't understand what the 10 centimeter represents.
Oh, 10 centimeters is this distance, the distance between here to here.
Oh, okay.
It's a paper,
okay.
yeah, it's A4, like 10 centimeters.
It's the horizontal one. And
Yeah. Actually, it's just a reference, because when you increase the width, the font, the text can be very small.
So all of these scripts, we can access them?
Sure, you already, it's
all the ones that you have shared with the...
Yeah, and everything is on the Dropbox.
On the Dropbox.
Yeah. And here I do a square, the longitude, latitude. No longitude, latitude, but left, right, and top and bottom. So when you want to do a map, you can, because when you choose the longitude, latitude, it's hard to fix the width and height. But here you can, because it's a ratio. So here I do the 30 kilometer from the center to each side, and then the GMT can automatically calculate the longitude, latitude. So that's very easy for me to do the map, and I can run the code with this map, very easy. So and if you rotate, for example, I give 90 degrees. 90 degrees means no rotation. So I can just do it's the AUV map. So sorry, it's here. Yeah, 90 degree means no rotation. Yeah, that's EPR. But if 81 is kind of the best I tested. And then that's so when you have the projection and the range, so that's and then you can do the you apply. So that's a feature in GMT6. For GMT5, you have to each layer you have to output to overlap the older layer. But this one, it's the GMT6 is much better. So here you give a you go. So here you give it's like this one is like you give the coordinate, then all the following layers are corresponding to the coordinate with longitude, latitude. And then this one is a CPT, so I choose Roma, and the depth of the color bar, and it's so it's and here is grid image. So if there is an option for the shadow. For example, if I don't do the shadow, it's the flat map. And if I give the shadow like bar, we don't need to remember what does C, I, T, the meaning. We just use it. I just use it. So
It works on mine.
yeah, because I put all the paths
Yes.
folder in your
GMT links to all the
link to just
data.
the local directly.
Okay.
So I think everyone can run
So
the code.
the EPR Magnos database, you can get it from the Discord in shared resource.
Yeah, you can also.
In Discord, I have only access to random. I don't see anything
Oh,
else.
what? Okay, let me fix that.
Yeah. And yeah, that's and if you add the eye and give a angle for the direction of the light, then you can get the shadow of the map.
Oh, I think it's because you have two different
Okay.
accounts. Okay.
So do you understand? If can continue, then so next step is so when you do GMT and if I stop here, it's just like this. So it's just a map without any. So if I add here, I add one more this one for the frame, the longitude, latitude, and here I rotate the latitude 10 degree, 9 degree to vertical. Here is the code is like oblique annotate. I don't know why it's 3, 4. You can find something like 1, 2, or very different. And the color bar with the PS scale is the color bar. So that's kind of the base map we use. Then we are going to add the features like the data, for example, this one, the AUV map, and I put the Lamont Pacific plate, and also the label A. So normally when here I already fixed the location of the Lamont, and normally we have to do give a longitude, latitude for each dot, each text. No, we don't need to do that anymore. So here I give a elegant way to do so the Lamont here, the text. So you just equal Lamont and then do the GMT text. So here is the key, this one. CTL means C, we don't need to know YC. So if you give a longitude, latitude, for example, here, you have to give it J, T and C, T and left. So CT at left means, for example, if I run a code like the GMT text plus F C. Okay. So if you put CM means the center of the map, so it's correspond to this one, the center of the map, and you put left top of the map, then it moves to the left top, but we don't see it because it's covered by A, and then you shift, so then you adjust the location, like by shift D, and I do like minus, so we 1C to the right, and minus 1 centimeter to the bottom.
And this is only in GMT6? Or this can be run in GMT?
For my code, you have to do it in 6. Yeah. Yeah. I only use.
This option that you have, that you
Oh, yeah, it's.
6.
I don't. Maybe it can be on 5. I don't know. I'm not sure.
So, Jay,
Yeah.
sorry, I haven't made a GMT map in 11 years. Can we just go back into a little bit of the more basic stuff
Yeah.
to start? So
Yeah, sure.
the
Oh, yeah. I should go start from the beginning,
yeah,
right?
Maybe let's walk through what this code does, right? Because the
Mm.
figure one.
Yeah. Figure 1 is the most important for this today.
Right.
For today, yeah.
So you do a bunch of GMT sets initially. I'm guessing that's just.
Yeah. So I want to introduce this one later, but because here is like I give the name and the source. Source means so the source. So it's very complicated maybe for the beginner, but it's okay. So because every map we made has a homogeneous setting, and you don't want to do the setting again. So I save all the
It's a
GMT, configuration by my default setting.
Okay, your default.
So I have the GMT starter, so that and you source it.
Oh, I see. Okay. So
Yeah.
like the projection units are.
Yeah, project color background, and maybe it's already default, but I just
Okay.
reinforce everything. And the color data and code is like this, because for one paper we use the same data and we want to keep the same color for the fourth and feature.
These are the path.
Yeah, the paths for the grade, bathymetry, and the text for the eruption vent area, and also the color. I define all the color in this path. So for all the figure in the same paper or the next paper, the follow-up paper, we can use the same color. Then all the publication, our color can be the same.
And
Cons-
it's useful when you do a presentation or a poster to have like all the figures in the same color scale, I think.
Yeah. So all the fort on, like for me, all the fort facing to the east, always red, and for the facing west is blue. And that's a local setting for this map. And then we go to this one,
But it's also
G-
possible to put that in the code. It's not necessary.
yeah,
And this is just a shell script.
yeah, shell script,
Call other shell scripts.
yeah.
Okay.
And then it's so now GMT6, we start from GMT begin, all the code, and you give so here I give the figure name and the figure format. So
I don't see your GMT begin. What line is it at?
in the end,
Oh, sure.
it's in the end. Begin I put that's no, it's very you will know why it makes sense.
Okay.
So
What line is it? I don't see it.
71, yeah, and
Oh, I see. Okay.
yeah, so that's GMT name is in the beginning, in the second line maybe, and the format I always put format as so I do like PDF and JPEG.
So the actual code that does the map starts at GMT begin, and everything you have above is a function that you define.
Yeah, it's like a MATLAB function.
Okay, I see.
Yeah. Yeah, that's the most elegant way I found for the GMT is I separate all the figure like panel A, panel B as a function.
I see.
So it's like if you combine all this panel model in one from it's very complex to find them. Then it's like we draw the map as we like draw by our hand, like the different model, different function.
Okay.
So you can see. So in my screen, you can see the panel A is EPR shape, and the plot globe and the plot AUV. So that's very elegant.
All right, because you have AUV data in the middle of that.
Yeah. AUV would be so AUV is here, the right panel.
Okay, so that's
Yeah.
panel B.
Yeah. So that's a structure for the code.
Okay.
And because when we do the shapeable symmetry, we don't need the globe, we don't need AUV. So I just run this one, the shapeable, because we want to save time. And I have another great way to save time is to lower the resolution of the symmetry. So I have two symmetries. This one is the original symmetry from Milena, and this one is low. This one low means so I do greater sample.
This is something you've done outside of GMT.
Yeah. No, it's GMT. It's the greater sample. It's in GMT.
Okay.
So it's like for example, I import the original symmetry and output the low resolution symmetry. So it's like 0.5 minute. So for example, it's like this. So I do low means very low because when you adjust the text, we don't need the. So we just like this, and I shift the text and change the. For example, I can change the text of this one, and but we want to keep the base map to see the relative location. So and it's more useful for the AUV symmetry.
Sure, because it's super high resolution.
Super high resolution, and it takes 1 hour maybe sometimes. Yeah. So and when you finalize the map, okay, let's see what's the final version of the symmetry. Then you just use the high resolution.
It's like I put my glasses on. Nice. And so can we walk through line 36 again? So you said initially you defined the projection properties.
Yeah, that's a projection.
Can you say again what R and J
Oh,
are real quick?
R is so we maybe start from J.
Okay.
So J is so this one is the center of the map, maybe somewhere here.
I'm adding comments.
Yeah.
What? Okay.
And the longitude, latitude, and the rotation 81. Oh, you can find it in here. Maybe the details of the.
So you have like something like 3D model.
Yeah, it's an oblique projection, and you can find all the. It's maybe more complexity than you want. Yeah.
So J is the outline. Center.
It's a center and the way of the projection.
Okay.
So OA is the oblique something.
Okay.
Yeah. So if, for example, if I do this 50 kilometer for the west, I will get bigger map. Yeah, like this. And if we want test, we can do like this, the lower resolution.
And what is plus UK?
Plus UK unit in kilometer.
Okay.
Yeah. And you can do maybe meter is E. So we normally we don't use the.
But in the version that I have here, you have R is -4, 4, -13, 13.
Yeah, minus means west or south.
But it doesn't seem to be kilometers. I have plus UK.
Yeah.
It can't be 13 kilometers. It's
No.
It doesn't really make sense. Oh, I'm sorry. I mean the EUV map. My bad.
Okay.
Okay.
Yeah. Yeah, you can shift, and even you can, the center is not necessary to be inside in your map, so you can do everything in positive.
And if you
just shift.
If you go beyond where you have data, it's just going to put some white space.
Yeah, if I put 100, so it beyond the perimetry. Yeah.
Okay.
Yeah, that's so I think that's the most important thing for the figure one for all the modular.
Yeah, just making a map in general. That's
yeah.
So okay, and then
Yeah.
and then GMT plot is actually what makes
Make
that produces the map.
Yeah, GMT plot had two meaning. So first one is when I do GMT plot bar T means I don't plot anything.
Okay.
But I give the coordinate, the range and the projection. So, yeah, frame, but it's not visible. Yeah, it's just the coordinate. And here is the same. I do.
Do you have to do this, or could you do everything at once?
No, you have to do
You
one.
have to do first the frame and then.
No, you can combine these two, because if I do for example, this one I give the frame. If I do this one first, and do the perimetry second, I will lose all the grid. So you can see this grid line, because it's covered by the perimetry.
It's just the order in which you go.
Yeah, the order of the layer. Yeah. And also the scale for the color bar here.
Okay.
Yeah, and you can put normally it's you can put the background in white and give transparency for the back of the color bar.
And you can also play with the frame, so sometimes you have this black and white instead of like for marking the degrees or minutes, you have the black and white.
Yeah.
So there are quite a lot of options.
Oh yeah, you mean the frame?
Yeah.
It's here the
classic GMT frame.
yeah, it's like this one is plan. It's fancy.
Is it actually called that?
Yeah, it's fancy.
Is the GMT name?
No,
No.
it should be fancy.
It is fancy.
Yeah, but I don't know why it's not fancy anymore. Now you can find it.
Yeah, but it's like in manual you have all the options.
Yeah. Maybe I don't know why.
And you can also define at once so if you want a minute or second or.
Oh yeah. This one's the format geomap. So this one is a degree, minute, second, and you can do. So if you want to for figure one, you want to have a simple another way. You can do this, the degree, and it's like. Yeah, decimal, yeah, you can see, but it's not, because here I define it like minute, so it's not the right way. And yeah, maybe.
And mix CPT is about the color map?
Yeah, color map.
Okay.
So it makes minus 3,100 is the bottom and the top, and the 15 the friction of the, yeah.
And GRU image, that's what actually puts the
perimetry. Yeah.
Okay.
So bar C is like I apply the CPT here. There another way is like you create, for example, you create a CPT file. For example, yeah, CPT.cpt, and then you don't need the CPT. You can do like this. So then you can use in the next figure.
Okay.
Yeah, you don't need to do the same every time, and you change it, and it's all, yeah, it's homogeneous it's global for everywhere. And there's another thing for the color bar. So here you can see is our perimetry is minus and in meter, but here the depth is, you see, it's positive and in kilometer. So that's a trick. So it's W, and you times minus 0.001, so it can be kilometer in depth.
Okay. So you multiply it by
Yeah.
0.0.
Yeah. It's easier for the figure because in meter the number is too long, so I prefer this way.
One thing that you have to be careful with this color
Yeah.
And I don't remember how. If you can tell us how it's discrete, because then you have like the bars.
Yeah, yeah,
have
yeah.
Orange, red.
Yeah, yeah, yeah.
Yellow.
So
And here it's a gradient.
see
so
this
it's
one? Is it you want the?
Yeah, yeah. This is you see. This
Yeah.
one is discrete, but the map is actually a gradient. So we need to make sure that.
That's
Can you show us how to do
So
that?
here you just changed.
it's
the,
Z. If you choose a continuous CPT or not continuous, yeah.
But that doesn't affect the figure itself, just when
Yeah,
the
yeah,
color
just
map is
yeah,
going.
yeah.
Oh, that depends. Okay, if I choose 100, then it affects the figure.
Oh,
Because-
you will see it. Okay,
Yeah,
you
yeah,
can
yeah.
see
You will see the. No. Yeah, you can see it.
more bands of
Yeah, yeah.
different color, okay.
It's good for the magnetic or something.
Yeah, or
Yeah.
if you want to plot velocity, this is the one that you use. Or
Yeah, yeah.
whatever, it's a model related.
Yeah.
You use discrete, but when you use the map, then it's more like gradient.
Yeah.
Velocity, like P wave.
Yeah, P wave. Yeah, yeah. And if you give Z the continuous, actually this 150 meter or 20 meter, it doesn't change too much.
Yeah, you don't see it in a low resolution.
Yeah, yeah. Yeah. And yeah, yeah.
And so the second geometry.
And this one, the I is the reverse. So I want to make the, yeah. So this one I need to reverse
Are
the,
there a bunch of default GMT color maps? Can you add color maps from like the Canary color maps?
yeah, so here is like Roma, and I can do the Hux Bean or something like all the paper yesterday shared by Ivan, something pasta. I don't have this one. Maybe they are not included in the
They had fun yesterday.
in
I was like, what is going on?
It's the same newspaper.
Oh, it is.
They're not
Yeah.
April Fools. Like,
Yeah.
There is another one, I think it's Italian researcher who did the very nice, I can send it, very nice color scheme.
yeah. You have to check the color bar. I have the so in last slide I have the color bar. You can find all the color bar in GMT. So it's good link for the you can find all the color bar here.
I would like to plot submarine relief like terrestrial relief with the same color scale, just to make a fake like terrestrial map.
Yeah.
With the
Uh,
colors we're used to.
Another one, normally if you want, so for me, I do mapping. First one is with color. The second, I give M, means I force the map to be gray. So this one is the key. If I give M, it should be gray in, and it's not. Yeah, it's like force everything in grayscale.
Can you also
Great.
force the color map to be grayscale with -m or?
No, I don't think. When you in gray the color, you don't need a color scale. This one.
But you could have you could do a color. You need a color map that shows the shades of gray.
Oh yeah, you have to. So then you have to use the.
You have to
Yeah, you pick the gray. That's yeah. Then you have to change the color scale. You can go beyond the real bathymetry range because sometimes you're too white, too dark.
Yeah,
So,
yeah, of course.
yeah. Yeah, sometimes you have to shift like 50 meter forward, backward to make a better map. I usually, it's for the color scale, it's very complicated to, yes, that's why I use Roma is my best color bar for the map for my current figures. Yeah.
Is Roma one of the Canary color maps, or it's
Oh, it's just from red to blue and.
No, but is that I forgot.
Oh, Roma is it's a map from the
Yeah.
Canary, Cameroon, all named by city.
Can you try Oléron? I like Oléron.
This one,
Yeah. I like this one.
it's
It's
O
like blue.
O L E E R O N.
I'm pretty sure he got the name from that meeting we had at Oléron in 2015.
Oh.
You're missing an R.
Oh yeah. Yeah, it's then if I miss something, it's a rainbow by default. Oh, that's your map.
Yeah. That's the maps of
Yeah, yours there. But you have to change the color scale, the range. Yeah, yeah,
but I know it's hard to see it.
yeah.
It's too bad.
Okay, so after color scale, can we go?
And so
Yeah.
what's that next GMT plot line looks awful. What does it do?
You mean this one?
No, the one right after Shibbatilo, after GRD image.
GRD image. This one?
Yeah, this one.
Oh, this one is so if we.
That one was very complicated.
No, it's not. No. So this is a frame. And so GMT plot T means you don't plot anything.
Okay.
And BNWES means you add the frame in 4 direction, and you only want the label, the annotate in capital NW, north and west.
Okay.
So you see the source is a little character here and E. So you just keep the one side. You don't. If I do S in capital, you can see. Yeah, you see everything here. And you can see the ticks. If you do S with button, you don't see the.
Oh, I see. Okay.
Yeah, you see nothing.
Above, below.
Yeah. So left, right, top, bottom means nothing, just a line.
Okay.
And west, east, capital, little, you can see the label and the ticks. So I think that's very convenient.
And so then after you got the BXA.
BX is
X.
the ticks for the X. So here is the A means annotate with 10 minutes,
10 minutes, yeah.
and 5 is a tick. So you see the small
Oh, yeah, the
5
small
minutes
one.
and grid in 10 minutes for X, and for the Y is like this. And the grid I give a dashed line, it's defined by this one. So if I want to do in red and 2P, the very thick red line, yeah, maybe it's not default. Yeah, it's in. You can change the color and gray, or you can remove by use the default. Yeah, it's just solid line. And this one, to rotate the longitude here if I remove this one, it's just horizontal.
Right.
And if you keep it, it's vertical. And you can also change this one, the latitude. I think it's 2, 3 or something. It's very complicated. Yeah, I don't know, the 1, 3 or 2, 3. There are many options to do the map. Yeah, it's very, so it can follow the grid line, or you can make it vertical. So, but for me, I use it, or you can use the default. It's very, you can check this in GMT, like search it. Yeah, here. There are many options. I think you can find it. There are many options.
Is ChatGPT good at generating?
Yeah, it's good. It's very good. Yeah. That's a good question. And then I can plot the AUV. So I show the AUV data. So that's VS Code. You can open many terminals, and then I can, and it's in the same path, and I can. So that's a AUV data range, and it's just longitude, latitude. So GMT plot and the file. So here the file you can use like this, or you can do something like you can AUV range, and we give $, and it's the same.
Wait, I don't understand what is in AUV. Oh, that's just a contour.
Yeah, just a contour. Yeah. And also you can, so W means the line, and you can feel the
contour.
Yeah, in red or something, or in some very complicated way. There are many options. You can feel like bubble, because when you do plot the basalt layer and dike layer, you can give the vertical line. Yeah, and the label, because I use all the same. So when I do the map, the label should be same. So here, the elegant way, I give the label name here. I give the command like GMT text and blah blah blah, and then I can use label name like as a function. So I equal A, and I do the label name here, put on the left top. So I give, so it's a CTL and shift to both right and bottom.
And this is in units of centimeters?
Yeah, centimeter.
Relative
to the width. Yeah. Then all the like the AUV map, so they should be the same location.
Yeah.
And when you do the very complex map, time figure like my bathymetry, you can put all the same position. And you can, when you change this one, you change automatically everywhere. Okay, so that's a map for the A. Then if we do the globe, so you just add the globe like this, then it's automatically added, and yeah, that's very fancy. Yeah.
Where do you define the plate boundaries?
That's my question.
Oh, the plate boundary, it's this one, the data from.
You have to add.
Yeah.
And the coast and everything, that's standard, that GMT has it.
Yeah, so if I first do the GMT coast, so maybe I can do like this. I remove the bathymetry and do the globe only. Then when you work on the globe, just work on. It's very efficient. And the globe G is the four from the four range of the globe. It's like from minus 180 to 180. And here I give the projection G. I've got there are many ways to close the globe, and here is just one of them. And 95 tan is the center of the map, and 3.5 centimeter is the width of the map, the globe.
So 95, 10?
Yeah.
That's a longitude, latitude?
Yeah.
Center of the globe.
Yeah. It's the center, maybe somewhere here.
America,
Yeah. And here is the grade of the grade here, 30 degree. Yeah. And A is, I think A is area. Okay. Area means sometimes you see the lake, sometimes you see the ocean. So you have a threshold to make classify the water body and land body. So it's like 100,000 kilometers square is the threshold for the lake or the ocean. Usually you can give just one. Yeah, you give one, then you have more lake. You see, you have more lake, and you give like, yeah, you can feel the small. Yeah, now you don't see the the 5 lake here. Yeah, and G means gray means for the color for the land, and S is color for the ocean. So I can give blue, then the color for the ocean is blue.
These are just contours. It doesn't have elevation.
No. Then that's the grade, the format for the grade. So then I do the math. Then do the. So this one is just it's just longitude, latitude. I don't change anything on this one, and give the line. Yeah, and then we see the So here I give the longitude, latitude for the, because I know it for the blue star and the text. So the text I give, so here it's sometimes it's very hard to plot the text because you have to find the right coordinate. But here you can see all the longitude, latitude are the same. So you just give one location, then shift the location to corresponding to the star. So here I do the text and make it fixed to the right middle and shift both up and down and the left to right. So you always, so it's very easy. It's like the relative position, not the absolute.
Relative to the star?
Yeah, relative to the star. Okay. So I think that's a very easy way to plot the text. If you change the longitude, latitude, it takes 1 hour to find the right place. And when you change the projection, it can change everything. So when you have this, maybe I should do this. When you have the globe, and if you plot it, it's here. It's actually in the lower left corner, because the orange position is here. So you have to move it to the right, your favorite position. So here I give, because I know the width and height is 10 centimeter and 10 centimeter here. So to move it to the up right corner, and the width of this globe is 3.5 centimeters. So you just move it to X. So I give X means shift to the right, Y shift to the right, to the top, like 6.4 centimeter. So you add 6.4 and 3.5 is 9.9, and then you have 0.1 centimeter the spacing with the frame. So it's like you have to calculate, but it's not very complicated way. It's very easy to just give the very good specific location for the globe. And it's very easy because you know all the width and height for the map. So elegant.
It seems like it's a bit squeezed on the horizontal, so is that the size that you gave for the map, or is it, what's the issue? It's not, it's like a...
Oh, you mean the map is not square?
No, the map, I don't see the map, but I see that it's not
The globe.
It's more like an egg.
No, I don't think it should. I think it's 3.5 should be.
I don't know.
Yeah, maybe it's no.
Maybe it's
Yeah, maybe it's. Oh, it's a screen.
okay.
Because here it's good.
It's circular.
Yeah. Yeah. So then you shift it to the top right. Then you have to shift back. So here I give a minus 0.4 centimeter to move the orange to the center, to the left here, because we are going to plot the next one, the AUV bathymetry. Then, so for the AUV bathymetry, so if I don't do the shift, they will collapse. No, it's not here. It's yeah. Maybe the resolution is too high, so I need to, yeah, they are collapsed into one. So I have to shift. So T means nothing and just shift, but you have to put it. So then that means I will have a new panel. Then you plot it and shift. So you can see the height are the same. You have to fix the height. So that's a very important thing for the mapping. You want to make the figure the same width or height. then I can, that's because I do the same for the, here you have the center, maybe the center is the same as the shape bulb symmetry, the AUV, and then you give the range, the width and height, then you have to calculate in MATLAB and calculate the right number for the width to have the same height for 10 centimeter. So that's fixed with the ratio is fixed. Then you just do the same. The GMT plot to apply the coordinate, give the color and the AUV and the frame and the color bar, the everything is the same, and I can plot the AUV, the melt range from Milena's reflection data. So I plot the AML range and the eruption area. So this the eruption, and also I plot the, because Jacques and Kim asked for the seismicity. So I plot the earthquake. So there is the earthquake. The earthquake had different depths. So I give the, so maybe I should open the text, the data. So this one is a test Tostal 2011, and the data is here. I define the path here, and if I open the folder, so that's the data I download from the Marine Geo website. And the format is like this. You have blah, 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 and here is the data. And I don't need so I just need this one. So I do a cut. And you find the day, time, and the year, and the latitude, longitude, and depth. But I don't need all the information. I just need the longitude, latitude, and the depth. So here is the column 8 is longitude. I use OC. I don't know if it's very simple. 8, 7, 9 is the longitude, latitude, and the depth. And that's the...
That's from their catalog, the different colors.
Yeah. And then you can do the plot. And here I do the circle. C is a circle. And A is a star. S is square. And C means I apply the color bar created by the Oslo. And W is the outline of the earthquake. So if I want to the uniform earthquake, I just plot the location. I don't need the color. Oh, maybe I should clear yeah. I can do this red for everything for the earthquake. If you want to have the color scale, I have to do C. G is field, and C is the color bar. And then finally, I do the vent in orange, so you can see the vent area. So the vent is from Junan's paper. It's and you can find it in the folder. Yeah, and B is equal B, and plot the label. So it's very easy to plot everything with very easy name, and yeah. And when you finish the figure, I just make everything in high resolution and just finish the figure in the end.
I don't know if what faults in the data you have this
Tick.
minus. Yeah. So how do you deal with that?
Oh, I have it's maybe the another example. Maybe you can jump to do you mean this one?
Yeah.
Yeah, it's, I don't know, it's figure which?
I mean, if you want to cover that, we can wait. It's not.
It's okay, it's the same. Yeah, it's the same thing. I think it's yeah, fourth. So it's figure 3. Yeah, that the second example is when you have the figure like this. So yeah, this figure had so in our field we have 3 panels, and each panel has the same width, height, longitude, latitude, the same frame, and they have the same label, and so they have many common features. And here they are, in GMT it's like a MATLAB subplot. In MATLAB, in GMT we also have the subplot something. Here I didn't do subplot. I just shifted the orange. So here I first create. So let me show you the first map. Here. Okay, the first map is the bathymetry we already know. And you can see when I give the coordinate and the bathymetry, I have the common plot. Common plot are here. I put the frame, the longitude, latitude, and the AML area and the eruption and some labels, and also the A and B, the label as a common. And so for the second figure, I just do the common, so you don't need to change. It's like MATLAB. And then you do when I do the fault with ticks, is this one. So I only plot this one. So it's so the data is so it's just longitude, latitude, but with different segment. You see the different segment, and you have the ticks like this. So you do this is the key. So that's a centimeter for the distance, and the distance, the length of the ticks. So that's a second 0.25, and F, the left means all the tick facing to the left, but left has, you have to make sure this is the starting point or here the starting point, because if you reverse the starting point and the end point, it shifts. So another way. So I have to, if I want to make the fault facing to the right side, I have to here the start, here the end, and for this figure, this fault, here the start, here the end. So yeah, that you can. I do that in Globe Mapper, so it's not a problem. And that's the W is the line, the width. So that's a fault, and also here the fault in I just feel the, and here the color for I can do this is the data, and this is the color feel the fault here, the orange, and here the outline are the same as the fault, the same color. And this one is a legend. So legend is here. So because I know the width of the map is 16 centimeter, so I shift it to 15.9 to the right and 0.1 to the top, and fix the orange of this legend to the bottom right corner. So the distance between the legend and the frame is 0.1 centimeter here and here. And you just add so you add the each features here, and the same. So you can change the here if you do so 0.1 centimeter, it's just a line. It's a fault. If you do this, you can modify it. It's very convenient to line or square or circle. So C is circle, A is star for the legend. Yeah, you can see the different label. And yeah.
Can you go back?
Yeah.
So what I was thinking about is
This one?
Is the data. If you look your data, you have the numbers, and then you have like a greater and greater sign there. No, in the data, not the graph. Look at the data where you have terminal and then next to the terminal you have the data, the left long.
You see this one?
Yeah, and then you have numbers and then the last line is yeah.
Yeah.
So how do you? I know that I always had a problem because this means that it's cutting the line.
It's a segment boundary.
It's a segmented line, but in the code you have to define this. And where do you define it?
Oh, it's GMT format.
Okay, so
Oh, you can do none, then it's same.
because I think in earlier versions of GMT you had to mark this.
Oh no, now you don't have that anymore. Yeah, that's modern GMT. Yeah. Yeah, that's so that's a figure for the legend, and
if you want to digitize something, when you want to define the segment of like you have 1 volt and the next one, you have to put this break in the text file.
Or do individual.
Yeah, or do individual files.
And actually, I have a folder like, so GMT they have a example folder. They put all the for example, the legend, PS legend. So you can find all the legend. So they have the script and the example. So if I open one of them, it's like you can find the. It's not working. Oh, I closed the, yeah. So I mean, in GMT, they have a test folder. They have all the model like project, PS, XY plot, and seismology. You can find all the examples by GMT, and you just copy you can find the same. Let me open one of them at least. Yeah, so they have for each like plot grid image, they have examples. So if you have problem with any model, like for example the grid image is here, and you can find it in the grid image, and you can find the code here. Then you can modify their code and to yours.
And so, just since we're running short on time, could you show us focal mechanisms?
Yeah. Focal mechanism. Yeah, that's focal mechanism. I checked that's a tricky. I checked the EPR. I don't find any focal mechanism from global CMT, but I found something along near the transform fault. So and then I download the data.
Is that one? Is that a real one?
No,
it's just a test. Oh, that's too bad.
Maybe that's J2030.
Okay, that's your prediction.
Okay, so that's the data I output from CMT catalog, and you just copy to the text file and run in the focal mechanism. So here is the same like.
So, wait. You just can you show me which format of the CMT catalog you use?
Okay.
When you take the CMT in a line like this.
Yeah.
Okay.
Yeah, this one. It's like it's very complicated.
No, but it's the condensed format.
Yeah. But for the GMT, it's super easy. So that's bathymetry and blah blah AUV. So for the focal mechanism, you just take column 1 to 10. Maybe I should open the CMT. Let me open the. No. Oh, it's here. So that's the data I download from the. So I only need about 10 column, first 1 to 10 to plot, and so I use awk to take all the data and just to do this. That's all.
Do you scale them by magnitude?
No, it's already automatic scaled. So you see some are small, some are big.
Yeah.
So you don't need to do anything.
Okay.
Yeah. Yeah. And if you, so I created some because when you talk about Fourier mechanism, we see the longitude, latitude, depth, and the strike, deep, rake, magnitude. That's when you do seismicity, we can calculate. So I created the longitude, latitude, depth in 2 kilometer, and here is a strike, deep, and rake, magnitude, and name. So that's an earthquake here. It's and another one, if the earthquake is very dense, so you have to do this, like a line to link.
Oh, yeah.
So then you give a new longitude, latitude here, and give a name, like, so it's automatically linked to the original position and here.
But where, okay, so that means, I understand, so GMT mecha over there,
Yeah.
above, it reads the standard GMT profile. So this is really individual components of the moment tensor, MRR, and
Yeah. So that's a CMT format. And
CMT format. So
yeah.
how do you get it to read your format?
Yeah, my format is this one. It's also very easy.
Okay, so the GMT can read both formats.
Yeah, both.
Okay.
But the difference is here SN, here SA, so that's a different.
That's how you tell it that you're going to give it a moment tensor?
Yeah, the format. So it has a Fourier mechanism. You can find the different format. Yeah, something like this. You can find example, and it may be easier to find it in the SAS tag folder. So you can find different Fourier mechanism, and even you can plot the probability like I did, like this one. So you can see when you do the earthquake, you have peaks and the probability. So you can find it in this one, and it's a GMT test. So it's in GitHub. So that's
GMT mecha, that's a standard.
Yeah,
GMT.
mecha is the standard. Everything is in this one, and you can find it here, and you can. But you have to run it in your computer. It's just a script.
Sure.
Yeah. Yeah, that's Fourier mechanism, and I think that's most of the presentation today. And here is just the same. The left, right. You don't need to do the longitude, latitude for the completed map. Here, a small one. And I think because the time is limited, and I also have a 3D map, and you can create a 3D and do manually work on it.
Right.
Yeah. And the last one is a Spielhaus. So that's I did for Jean Arthur and the guy in IPGP for the global earthquake and the peridotite, and also for the fat data science. And here I have very easy way to do the earthquake. For example, I already created something, so you just do it. So I have the GMT, the Spielhaus is here, the data. Everything is in my GMT mapping Spielhaus. So I created all the Spielhaus map in the same format. So the key is you just overlap. So So if you want to do something new, you have to ask me to create a new speedhouse. So the thing is like for the hydrothermal vent, you do like, plot, I first give a coordinate, a fake one. The coordinate is from -1 to 1 and 20 centimeter width and height. And that's if you do the coordinate like this, but we don't need it. So I gave B0. That means I just need the frame without the label annotate. Then I have the plot image. It's a common. It's this one is a function, and the plot ocean means speedhouse roller bar ocean.png in this folder, and the plot ocean and add the frame, add the land, add the change, mid-ocean ridge, and the vent. Then add the text. The text is like the fake coordinate, longitude, latitude, like, so it's like this. Yeah, it's a coordinate -1 and 1. So I do it manually to put the Mars where this label.
These are coordinates in the frame of the figure.
Yeah, in the figure, it's fake coordinate.
Okay.
It's not a longitude, latitude.
Because it would be horrible to track.
Yeah. It's coordinate here. You can also find if you want to plot lucky strike, you need to do open B, the frame, and you find lucky strike somewhere here. It's -4, and then you give a star.
You lose the ability to position yourself on.
Yeah. I hope someday they can do the.
I mean, there's a mapping. Analytical solution.
But it's good enough for us for map. Yeah, that's most of my. Yeah, that's all. Most of the thing I prepared, and the time is good. Okay.
I want to see my code.
And you can find the code, and I think if you have problem with your computer, you can ask me I can fix the problem maybe. You already finished.
You already asked you.
Yeah.
Thanks, dear.
Yeah.
That was very cool.
Okay.
It's good to have everything in one place because I had a folder and then I was just like going from one script to the other.
Yeah, for you it's very most useful for you for EPR. Yeah.
Great. And so for next week, if you'd like to do with me